Hello, my name is Bill Brosend. I am a Senior Applications Engineer with PBC Linear. In this segment, we would like to discuss an acronym we call P.O.S.T.L.U.D.E.S.
There are many factors to consider when selecting the correct product, and as you will see, P.O.S.T.L.U.D.E.S will quickly guide you with the key questions to ask in determining the right product for the job. P represents the precision required in accuracy or repeatability. Most users will tell you that their main concern is the repeatability of the product, usually in terms of repeatability of a movement to a position. Other users will tell you the smoothness of the move or noise is their major concern. O is for orientation. It is very important to understand the orientation of the product, whether the product will be mounted in the traditional horizontal fashion, or will it be mounted horizontal inverted, maybe on an angle, or even on its side. In any case, the selection of a product may be greatly affected by its orientation. S is for speed. Speed includes the velocity, acceleration, and deceleration of the load being moved. This also relates to the motion profile of the load, whether the load motion is triangular, trapezoidal, or S-curve. The dynamic motion of the load plays a large role in determining the right product to select. T is for travel or stroke. Not only does the initial length of travel need to be accounted for, the total distance for movement will need to be considered, such as over travel lengths due to acceleration or deceleration, or maybe additional length due to clearances or staging areas. L is for load. In simple terms, the load is the mass acting on the carriage, but other loading will need to be considered, such as end-of-arm tooling, fixturing, cutting or pushing forces. Off-center loads create moment loading, such as roll, pitch, and yaw, all which will need to be accounted for when selecting the proper product. U is for the unknown. Consider what could go wrong. If you don't know what could go wrong, there is someone who will tell you. His name is Murphy. D is for duty cycle. What is the product's expected life? How many cycles per hour, hours per day, days per week, weeks per year will the product be expected to perform without failure? This is a question quite often missed. But when the product fails, the customer is quick to question product durability. E is for environment. Consider the environment the product will be within, such as humid, dust, abrasive dust, chemical, washdown, etc. Environment includes all of the external factors influencing the life of the product, including maintenance and its frequency. The environment will surely influence which product is best for the situation. S is for safety. Are there any safeguards or standards the product will be required to meet? This would include such requirements as, does a screw-driven slide need to have the screw covered? Does the actuator need a dust cover? Or does the product need to meet any clean room standards? These are some items to consider. Other information to collect includes getting the basic application description. What will the product be used for? A couple of descriptive sentences will greatly help. Commercial information, such as what are the annual volumes? What is the target price? Who are we competing against? What is the rough timing for prototypes and production parts? Try to get a drawing, a sketch or model of the application, because a picture is worth 1,000 words. Another tool we utilize to collect data is the use of our Budgetary application workbook. This is a great tool to use as a checklist. Sheet 1, we ask for project description, project status, timing, quantity of product, and a target price. Also, we ask for general customer information, For Sheet 2, we ask for details of the application, which includes the scope of supply, the system configuration, system orientation, axis orientation, loading and moment loading, product accuracy and repeatability, and then its environmental conditions. For Sheet 3, we ask for the motion profile, which includes speed, acceleration, deceleration of the load.